Have you ever wanted to get a little competitive edge in a family board game? Well, our next speakers took that to a whole new level by coding their own expansion pack. This is a fantastic story of playful learning, computational thinking, and family collaboration. Please join me in welcoming Fay Shaw from PyLadies Boston and her co-developer and son, Hudson.
Hi, I'm Fay, and I'm an organizer for PyLadies Boston.
Hi, I'm Hudson, and I'm 9 years old. Fay's my mom.
And together we wrote a random route generator for Ticket to Ride. Today we're going to talk about the motivation behind this project. We'll talk about the game, the challenges that came along the way, and how we approached them, computational thinking as a method of problem solving, and what we thought about it at the end. At home, we play a lot of board games, and one of our favorites is Ticket to Ride. And why are we talking about Ticket to Ride?
Because I beat you.
And how do you beat me?
I know all the routes and can block you.
Maybe I can win if Hudson doesn't know all the routes.
So how do you play Ticket to Ride? Here is a board of Ticket to Ride. It has cities connected by train routes. You score points by completing routes. The point value is the shortest distance. To complete routes, you collect colorful cards and play them matching the map. You also earn points for each train you put down. There are 47 cities and 52 routes. The challenge is because there are a limited number of routes, I know where you're going and can block. So, we can choose more routes by picking 2 cities at random.
We can do this by importing the random module, and we represent the cities as a list and pick 2 from them. And here is sample output.
We can figure out the total number of possible routes.
We can use a combinatorics equation for n choose 2. Out of n items, we choose k of them. For our problem, we have 47 cities, and we choose 2.
So there's 1,081 possible routes.
The next challenge is how to get the point value for each route, which is determined by the shortest route. Generating random routes for Ticket to Ride is a good way to practice computational thinking. You might hear about computational thinking in education and preparation for STEM fields and promoting digital literacy. It is not just the code part of computer science, but a framework for critical thinking. Here are some of their parts. Decomposition is breaking down problems into smaller ones. Abstraction is finding a representation, simplifying details. Algorithmic thinking is following a systematic, step-by-step solution, and testing and iteration is trying out and improving our solution.
First is decomposition. We wanted to look at the shortest distance between cities. We started small, just 7 cities in northwestern Europe. We decomposed a bigger problem into a smaller one. Here's just a smaller version of it without the other part of the map. Next, we looked at how to represent our route. We have a graph. Cities are nodes, routes are edges. Here's the graph labeled with the city names and distances. This is a dictionary representing all the routes. Each city is a key with the neighbors and distance as values. Here is how we calculate the shortest route. Goal: find the shortest distance from a search city to any other city on the map. Find the distance from steps are: find the distance from a start city to a connected city. Neighbors. Mark cities visited. From the visited cities, find the distance to their neighbors and updated their shortest routes, except in that order. Repeat until all cities in the map are visited. For this example, we want to find the shortest distance from Edinburgh. Edinburgh is 0 from itself. Then we look at Edinburgh's neighbor London, and its distance is 4. London's neighbors are Dieppe and Amsterdam. Dieppe's neighbors are Brest, Paris, and Brussels. Amsterdam neighbors is also Brussels, so we can update the shortest distance from 8 to 7.
So here's the code. We have a function called Dijkstra, and it takes the train routes and the start city. We set all the distances to infinity. We initialize that shortest route from itself to be 0. We make a queue that's the order of visiting cities, and then eventually we process all the cities and the queue is empty. In the end, we return a dictionary of cities and their shortest route. Here's the output. Here's the function Dijkstra given Edinburgh as its input argument, and we get the same dictionary that we got when we figured it out by hand.
This is a list of all the cities in connection on the whole board. There's a lot of typing. It takes too long to type in all the cities, unless if you're a fast typer.
Can we use ChatGPT? We took a little AI side quest.
We uploaded the picture of the board with our prompt. This is a map of Ticket to Ride. The orange circles are cities. The name next to the circles are in brown capital letters. I want to generate a dictionary of the cities and their connections. Each city in the dictionary has an entry with a format like this. Then we told what part of the map looks like.
So was ChatGPT better than typing?
Yes.
Really? It made some mistakes and even made up some cities, even though you had to check them all?
Yes.
So by now we were running our random route generator, but we were just choosing cities and computing the shortest route. We wanted to make it more like a game. We wanted to keep track of player hands, view and hide, and discard routes. So we made a play game function, and it has a welcome, a card drawing function, and keeps track of player hands. It also calculates the total score if you finish them all.
Now it's time for our play game demo.
So here we're playing the Ticket to Ride game in our Jupyter Notebook.
So, Stockholm to Lisboa is our-ish, like center-ish. Stockholm, London to Kiev. No, I don't think that. Moscow to Athena. I don't like this.
You probably wouldn't have gotten all these long routes in a real game, right? But you can keep 2. Okay, my turn. Zurich to Rostov, Brest to Marseille, Petrograd. I think I'm going to choose the middle 2, because the other ones are kind of far. And by middle 2, I mean the 1st and the 4th. Okay, then I can hide my results. Okay, next. Hudson is going to continue the game by drawing some cards. He has to choose.
Wait, what?
He drew 3.
Get what I had. Oh yeah, because each of my legs, because it was like on the way. Pamplona to Stockholm. That's also on the way. And Petrograd, that's not on the way.
And I can continue by viewing my cards. And I can see what I have. And I can hide the results.
can also end the game, which just tallies up the score.
So in the end, Hudson has 67 and I have 19, and Hudson wins again. Thank you for playing the expansion pack.
I think you should have done.
Alright, so we did some play testing.
So we played it 6 or more times. This was when we just chose 2 cities and counted the shortest route by hand.
And Hudson said,
I'll decide if it's fun after we score the points.
and then Hudson won. And then what did you think?
There's more strategy since there are longer routes.
So we generated routes that are longer than the board game. And then we played where we calculated the shortest route. And then what happened?
I won.
And we had a little reflection. Anything happen in this game that didn't happen in the other game?
You messed up.
Anything else about the distribution of routes?
There's a lot of 4 routes. Like 1, 2, 3, 4, 5, 6, 7, 8.
So these are routes of length 4. Which game was more fun? This game or the first game?
This came because you blocked.
Anything else?
I liked how there were 4 routes in the way. Like you had to go on the 4 routes or go around, so it was more.
So you had to put more trains down?
Yeah.
Okay. Do you have any new strategies?
No.
My new strategy is go for the single routes, the ones where there isn't a second one next to it. This was our last play test after we wrote the game, and I won. Hudson completed 6 routes, so it was really close. I won because I had the longest route. So these were the challenges and how we approached them. We needed more routes. We had to score the routes. We had to type in the routes, and we made it into a game. So in the end, who won?
Mostly me.
Was it more fun?
Yeah, it was fun because you couldn't predict where the other person was going.
So in the future, what should we do to improve it?
We should put more players in there, since it's only 2 players.
Yeah, right now we only wrote the code for 2 players. And then, should we print cards?
Now there are 1,081. That's too many.
I would love to get a little tape printer, and then we could print them out on a little tape register. Would we want to do this with other Ticket to Ride sets?
Maybe US and Italy.
Well, thank you for listening to our talk. Please check our code on GitHub to play the game, connect on LinkedIn, and please check out the PyLadies Boston chapter.
How wonderful was that? A huge thank you to Fay and Hudson for sharing their fantastic project with us. It was a beautiful demonstration of how coding can be a fun, collaborative family activity. You have not only built a way to make your favorite game more unpredictable, but also a core memory of creating something together. And Hudson, congratulations on still holding that winning streak. Let's hear it for them one more time.